Preston Physics Grade 11 Waves and Sound Note 1 Periodic Motion. When we're looking at periodic motion, we're going to look at three different types of periodic motion. The first one is transverse. Now, this is almost like a sine wave if you think about it. Transverse periodic motion is a wave or a vibration that acts perpendicular to the rest axis. So the reason I said it acts almost like a sine wave is because when you draw it, you have your rest axis and it's going up and down around the rest axis like a sine wave. Then we have longitudinal. Now this one is a little bit different. This is a wave or vibration that acts parallel to the rest axis. A good example of this is thinking of a slinky. If you're pushing the slinky back and forth towards one another. So you have some extensions and some contractions in the slinky. Finally, we have torsional. Now, torsional periodic motion is a wave or a vibration that acts around the rest axis. This would be like spinning a string where you're spinning it around, so you have that torsion acting. We're now going to look at three definitions about waves that we talked about last year in grade 10, as well as one additional one. The first we're going to look at is amplitude. And this is the displacement of a wave from the rest axis. We normally represent this with the letter A. So it can either be up to the trough or down to the crest. It doesn't matter which one, it's the same distance each time. The second thing we're going to look at is the period, which is represented with a capital T. Now this is the time taken to complete one complete cycle, so to go back and forth. You have to get back to the start of the cycle for one period to be finished. Next, we'll look at frequency, which is a lowercase f. And this is the amount of waves that pass in 1 second, or the amount of cycles that occur in 1 second. We measure this in hertz. Finally is phase. Now things are either in phase or out of phase. To compare these two, we're going to imagine windshield wipers. Now if they're in phase, the two wipers are going to go together. If they're out of phase, they're going to oppose each other or really do anything else other than going together. They could go together, away from each other, it doesn't matter as long as they're not moving together. Now the last thing that we're going to look at is a period versus frequency. Now remember, a period is the amount of cycles that occur in a specific amount of time. So we want one cycle to occur in some amount of time. So that's measured in seconds. Now frequency is measured in hertz, and that's how many cycles happen per second. Or 1/seconds is also hertz. These two variables are the inverse of one another, meaning that if we solve for t, then we have to do 1/frequency, or frequency is equal to 1/t. The questions associated with this note are 1 to 3 in your yellow duotangs.